All right, let's just dive right into it. Welcome back to this deep dive explainer. Today we're tearing into the absolute bleeding edge of on-chain authority, decentralized organization, and identity. We're moving way past simple wallet addresses here, getting deep into how digital systems can autonomously organize, delegate, and act with just absolute certainty. It is a wildly fascinating evolution from where we started, so grab your notes and let's get into it.
So, here's our roadmap for today to keep us on track. First, we'll look at the decentralized identity paradox, then HATS protocol and local authority, followed by the hierarchical bitmap tree, the namespace synthesis, the LNA-33X bitpacking protocol, and finally, how we achieve semantic containment. Let's go. Okay, I want to start by asking you a quick question. How exactly do you give a smart contract a job title? Really, think about it for a second. In a traditional company, you've got an org chart, right? You know exactly who the VP of engineering is, and more importantly, what they're actually allowed to do. But in a decentralized Web3 environment, defining who can do what without relying on a centralized boss is just a massive organizational challenge. It's not just about identity anymore, it's about verifiable authority. Which brings us to section 1, the decentralized identity paradox. Right, so this right here is the core tension. Think of it like a digital Hegelian dialectic. On one side, you have the thesis, which is the Ethereum Name Service, or ENS. ENS represents your global identity namespace. Basically, it tells the entire network who you are. But on the other side, we have the antithesis, HATS protocol. HATS represents a local authority namespace. It tells a specific network what you can do. One uses namehash, the other uses a bitmap tree. Two totally different paradigms. Now, the structural limitation of legacy namespaces like ENS is that they're fundamentally indirect mappers. What does that mean? Well, if you own alice.eth, that name itself doesn't actually possess technical authority. It requires an external registry and a resolver contract to map that symbolic human-readable name to a machine-readable state like a wallet address. Without those external off-chain mappers, the name itself is literally just a symbol. It can't execute a single action on its own. So let's look at the solution to that in Section 2, HATS protocol and local authority.
HATS protocol takes an organization and turns it into a programmable digital object using something called role-based access control, or RBAC. By representing roles, which you guessed it, they call HATS, as ERC 1155 tokens, we shift from mere identity to actual, tangible utility. But unlike your typical NFTs, these are completely non-transferable, and crucially, they are revocable. If an address wears a hat, it instantly gains all the authorities bundled with that specific role. We're talking signing a multi-sig transaction, accessing a gated workspace, you name it. It's basically the ultimate on-chain organizational chart.
All right, let's look under the hood. Section 3, the hierarchical bitmap tree. So HATS operates using a 32-byte or 256-bit HAT ID bitmap. It's essentially a giant mathematical tree. The first 4 bytes are reserved for the top hat, which is the absolute root of the organization. After that, the remaining 224 bits of address space are sliced up into 14 distinct 16-bit chunks. Each of those 16-bit chunks represents a single hat level, going all the way down to level 14. To put that into perspective, this gives a single tree the theoretical capacity to hold well beyond the number of stars in the observable universe. It is incredibly vast. But why does this actually matter to you? Well, it comes down to something called structural legibility. Because the entire administrative lineage of a role is literally hard-coded directly into those 32 bytes, a smart contract doesn't have to perform expensive, clunky, recursive lookups to figure out who's actually in charge. You determine an admin with O of 1 complexity, meaning instant, constant-time verification, simply by inspecting the bitmap ID. For DAOs that are trying to instantly and cheaply command hardware or AI agents, this efficiency is an absolute game-changer, for sure. Moving right along to Section 4, the namespace synthesis. This synthesis is referred to in the source material as island hats. Think about it this way. If HATS protocol acts like a structural org chart, island hats acts a lot more like biological DNA. It completely synthesizes the global reach of ENS with the granular role management of HATS protocol. By doing this, it actually embeds semantic meaning into the very structure of the on-chain data itself. Let's break down the math. Section 5, the LNA-33X bitpacking protocol. To achieve this high-fidelity storage, the ERC 7827 standard uses the LNA-33X codec. Essentially, it takes a single 32-byte EVM word and partitions it strictly into a 3:3:26 ratio. Let's look at exactly what gets packed into those 3 slices. Okay, so the first 3 bytes act as a link, pointing to a previous nonce. This enables long string concatenation, which means you can totally bypass the standard 32-byte limit to support really complex hierarchical handles. Then, the next 3 bytes act as a nonce. That's a one-way, non-repeating number guaranteeing finality in the forensic record. And finally, you have a massive 26-byte slice reserved strictly for ASCII. That right there is the human-readable payload, and it's bit perfectly aligned with the ENS namespace.
Bringing it all together in Section 6, achieving semantic containment.
Here's exactly how this automated process plays out. Step 1. The system reads the LNA-33X 32-byte payload. Step 2. Instead of looking around for manual tree links, it executes prefix scanning. Basically, it reads the first part of a digital name tag to verify the lineage, and it does this directly on the 26-byte ASCII segment. Then, Step 3. Ownership of the parent namespace automatically grants the authority to realize child shards based on that derived prefix. It completely bypasses off-chain mappers. The final outcome of all this is a symbolic, self-mapping namespace. The name itself literally becomes the coordinate. There is absolutely no external registry mapping a string to a state anymore. The ASCII payload inside that LNA-33X token, that is the fundamental machine truth. You possess the token, you automatically possess the authorization to act. It's that simple.
I really want to highlight this quote from the ERC's 7827 Master Realization Report because it hits the nail on the head. It calls this architecture an operating system for sovereign authorship anchored in deterministic truth. We are quite literally witnessing a massive paradigm shift here, moving away from probabilistic digital approximations and toward an unstoppable, self-resolving infrastructure that commands physical and digital assets with zero ambiguity.
So I'm going to leave you with a provocative thought to chew on today. When your name isn't just some label, but literally becomes your absolute, hard-coded on-chain authority, how will you organize your own digital future? I mean, the tools are here, the architecture is live, and the possibilities are practically endless. Thanks so much for learning with me today on this explainer. I'll catch you in the next one.